Hey guys, I have this really crazy, presumably antique metal cutting saw here. Sawmaster. That's about all I know. My dad sent this my way, and figured I'd give it a shot. I was going to just use a cutoff wheel, and then I remembered I had this thing to play with. What I think is so funny is the way this thing works. It reciprocates like a human hand. I mean, it's like, how do you make an automatic saw for cutting metal? Well, humans use hacksaws, so make an automated hacksaw. I think it's just kind of a hilarious concept. That said, this thing weighs like 300 pounds and takes 2 people to get in here. Thankfully, it's on casters beyond that, so I can move this anywhere in my shop just fine. I haven't even plugged this in yet, so you guys will get to explore this in real time with me. Might as well oil it up a little bit. Added some oil in here. I don't have a manual. I haven't looked this up. Oh yeah, I can see there's another little spot right there to add oil. And right there. This one is missing its cover. So yeah, it looks like that's the way you add oil to it rather than using a grease gun. Normally when you see these kinds of old toggle switches, it means that the unit's quite old. And for the blade itself, I'm going to put a little cutting oil down. Time to plug it in. I'll be damned. Look at that. How ridiculous is that? Uh-oh. Uh-oh. She's slowing down. Why it's turning on and off. It looks like it's turning on and off. Either that or there's some kind of governor or something. Oh, shit. What's she doing? Is she skipping? Or is that some kind of commutator? Maybe this is a universal motor. It has some kind of, maybe, actually, you know what it probably is a brush. It's probably a universal motor with a brush. So I bet it's just losing contact. And if that's the case, it shouldn't be too dangerous to just see how it goes. Maybe. I mean, it's doing what it's supposed to do, but it sure is taking its time. So this must have been made back when people had patience. Because even with a fresh blade, it cuts about the speed of a person cutting, which is, you know, what you'd expect. Alright, so the trick to it, I figured out after mucking around for a while, is if you put a little bit of pressure on this side, and I suspect there may be a counterweight or a tensioner, this spring may actually be a very rudimentary tensioner. I'll have to look up, if I can find the manual, I should be able to find out everything else I need to know about this, but you put a little bit of weight on the side, and that slow sort of erosion effect that emulates a person's arm becomes much more powerful. See, this blade is quite thick. It's at least 1 millimeter, maybe more, which is unusual. You don't see hacksaw blades like that because you can tension them, and indeed this has a tensioner as well. So it caused me to riddle why on earth it's such a thick blade. Offhand, heatsink, probably also to avoid deflection. I was browsing the manual I managed to dig up last night, and a few things surprised me. One of the biggest things that surprised me was just how old this is. It's probably from the 1930s. There was a model number that was quite a ways ahead of mine, and that was from 1937. So this is probably from maybe 1935 or something, I don't know. I don't know how many they produced in a year. These do seem to be common, these automated hacksaws. However, they're not worth much. People practically give them away. So it's probably not worth more than $50 or so is my guess, in spite of it being pretty antique. So I'm very impressed at how old this is, and it does explain the bizarre engineering behind it. You know, flathead screws, these interesting oil openings here rather than using some kind of normal bearings. They're oil impregnated bearings as well, rather than having moving parts and using ball bearings. So there's just lots of little details like that. Another piece is there's supposed to be a wick. I don't remember from reading the manual a few days ago where that wick is, but for all I know, all of these are wicks. Yeah, that would actually make a lot of sense, come to think of it. If they had stuck a little bit of fiber in each of these, then this would act more like a reservoir, or just sort of slowly drip it. And you're supposed to oil this several times a day under constant duty. So it makes sense why a wick with a small reservoir would actually work. I have the feeling this machine was very abused, but perhaps not under constant duty, so maybe it didn't matter so much. But then again, since it has been Frankensteined, maybe it did actually get overused. I don't know, so many questions, so few answers. So I've fixed the tensioner. This is just a very simple thing I did. I don't have a good spring for it. I had a spring, and it's okay. Now you can see, I don't know if this is how it originally was, because the diagrams are kind of vague and I don't have them in front of me, but I put a carriage ball through here. Actually used a grinder to notch so that the spring would go through it, so it would hold it in position, so that I could use a lock nut, nylon lock nut. So that'll hold it in position and allow me to change it without having to grab anything below. So the tensioner is just this one spring here, and that's it. And it certainly adds some force to it. I think a better spring would be the way to go. So that cam removes some of the tension so that it's only applying force when it's in the backswing. Now this was definitely used as a weight. That's what they did right there. And you may notice this piece looks particularly familiar because it's the same exact piece that goes here. So I believe what's happened is they've probably sort of Frankenstein together this unit over the years, or I should say the many decades. Alright, so I've made some modifications. Here I have a shut-off switch to automatically turn the saw off. Actually tried to fabricate one to match the original design from like the 1930s. And I got pretty far with this really hard material here, but I'm just concerned that I could not reliably hit that switch. You know, I'd have to modify so much of this saw to make that really work without having the original piece. Figured it'd be good to know the actual amount of amperage, so I have a kilowatt right here. Alright, well, I'm going to go ahead and start this thing up. I would put cutting oil on it, but I'm going to see how it fares without it, I think. Oh, that didn't work. Wow, I'm surprised it worked to shut this off. If it even did work, maybe oh, it didn't work. It didn't work at all. Actually, what happened was this contacted that, and it hit the GFCI. Well, yeah, that's not too surprising, actually. Woo! So what I realized right away when I saw this thing moving, because I threw this together in my head without seeing it moving fresh, was the obvious solution is to put that toggle switch right around here, you know, so that it hits it without that sawing motion being a factor. I don't know how I missed that. Oh my. Wow. You know, I had thought maybe conservatively this thing was 10 amps or something, because, you know, it has a lot of moving parts, and all of that kinetic conversion does have a cost of friction. However, this is only drawing about 2 amps, which is insanely low compared to a modern power tool. And I guess it makes sense in retrospect. It's moving so slowly. The other thing is you can speed this up or slow it down by switching out the pulley, which is kind of a funny thing. Things don't usually operate that way these days, other than maybe drill presses. That would probably draw another, you know, half an amp to an amp, I'm guessing. If I was to, you know, maybe double it up, something around there, maybe 4 amps at most. The real concern would be, will the motor last as long if I do that? The quality of the cut is something people were talking about. Apparently you get a really nice straight cut with this saw. Is it any better than other saws? I can't visually see any kind of deviation, but I know that this saw is not perfect. You can see right here, has some real wiggle, but on the flip side of that, this blade is very stiff, it's very thick, and once it starts to dig in, it's going to follow that path. Oh, there is actually one other reason for this saw. Depending on the material, you're going to have less differential heating, which means you will get a straighter cut overall. So for example, if I have a high-speed cut, and I'm starting up here, all of that heat is transferring down as you're removing the material because of friction, and so this is going to slightly expand a little bit. So I suppose if you think about it in that sense, this would produce a straighter cut just because it's really not getting that much hotter. It runs pretty cool. I can feel a little bit of a lip around all of the cuts. There's more of a lip going that direction, but there's definitely a little bit of a lip. So if you were looking for a really clean cut, you'd have to file the edges still. Actually, that's the case with the other side too. This was cut with a modern saw of some kind. I don't remember if I did it or somebody else did it, though. I did it because it's not straight. So I think officially this is probably the best metal cutting tool I have in terms of accuracy, which, you know, given the age of it, is actually pretty good. Alright, now that I've had some time to kind of look at this fresh, I went ahead and switch this over so that it will turn off. To prevent GFCI shorting, I have a little felt nub on the end of this bolt here, and it's a little bit cleaner. I tied it right into this box here. I'll probably wrap that with a layer of some bicycle tire rubber or something I find laying around before I cinch up the screws. So at this point, it's good to test. And for expediency and the fact that I don't have any other metal laying around, I'm just cutting through some of this old hardwood floor that's split up and busted. Oh, gorgeous! Now the only problem with the way I'm doing this is that once I lift this up, it'll start back up. So what I have to do is manually hit that switch. I'm just not confident that I'm going to be able to come up with something better that's more reliable than this kind of setup here using an electric switch. So yeah, I think that does the trick. I went ahead and put this guard back on since it was included. I think that's about all that's included, honestly. The rest of this stuff is like spare parts that, you know, there's a piece right here, I think, for clamping and pushing things that way. It's my guess. I'd have to look at the manual again, which I'll go ahead and post in the description for this video. Interestingly, there is no guard for this. This is designed to be wide open like it is. I do believe there's supposed to be a wick in all of these, and that's missing, but I won't have this under enough continuous duty for it to matter. And then the only other thing is I still have to hot glue these contacts, and if I understand the wiring correctly, this is actually hot right now. So I think this is turning this off at the moment, the way this is set up. I would have preferred it the opposite way, but I didn't really want to hassle with it too much. I still need to replace this spring right here with something about twice as robust. One thing I wanted to mention about the idea that this shuts off when it goes down, and then if I lift it back up, it starts back up immediately. It might have an advantage, actually. According to the operator's manual, this thing should be moving when you set it onto the material that you're cutting. Otherwise, it can stall out, supposedly. I've started it a bunch of times now without it, directly on the material that it's cutting without problem. But I could potentially see, with the right situation and the right hardness of steel maybe or something like that, that it might get stuck. It also depends on your TPI and other factors involved in the blade itself. But it's something to keep in mind, and yeah, potentially this setup is advantageous in the sense that I could lift this up and it would immediately be going, but for example, if I had the same piece of stock and all I did was loosen it, lift this up, push it forward, clamp it real quick, set it down, if I was doing a whole bunch of those, like some 2-inch cuts, I don't know, 50 times or something, I could see that kind of control, the ability to do, to not have to keep pushing this thing up every time manually. I could see some advantages to having a little switch like this in place instead. So I hope you found this blast from the past pretty interesting. If you enjoyed this video, please like and subscribe, and I'll keep them coming. Thanks for watching.